Good afternoon. Welcome to Medical Grand Rounds. I'm Bob Wachter, Chair of the Department of Medicine. Welcome back. We took the summer off and we're starting, I think, an incredibly exciting series of conferences. It will now be every Tuesday that all of you who are here and online have figured out. We've changed the day to sync up with our other sites and to sync with the House Dev schedules as well. A couple of quick announcements. As those of you who are here see that we're in HSW today, that's a one-off. We're moving to S214, which is on the second floor of Medical Sciences, about 100 yards to the west of the Moffitt Cafeteria. If you need to ground yourself, we will be there at least for the next year or so. The reason we're out of the nursing building is they're going to be tearing down the nursing building sometime in the next few months. Second announcement is we'll be sending out in the next couple of days a notice for people who are interested in applying for the position of running these grand rounds, a position that Lakshmi Santosh has done with great distinction for the last few years. Lakshmi, as you know, is assuming her new role as Associate Chair for People Development and Mentorship, so that role will open, and this will be the person who helps plan the conference's topics, speakers, innovations, and this is a conference now that gets 30 to 50 people here, 100 to 200 people online, and we've had something like 5 million visitors on YouTube over the last few years. So it's pretty impactful, as they say in Silicon Valley, way of scaling education. So hope if folks are potentially interested that they will apply. Today we're going to talk about artificial intelligence. People said to me, well, we've talked about that a few times in the last few years. Yes, I think it is going to be the most important issue in healthcare over the next 10 years, so it deserves this kind of emphasis. And today we're doing a little bit of a different spin, not talking about the issues cosmically as much as talking about what's happening at UCSF and in our department. And there's a ton of things that are happening that are interesting and exciting across all of our missions, across clinical care and education and research. And we are having 4 of our leaders in various domains talk a little bit about what they're doing, what they're seeing, and helping to map out a future. My goal as chair is this is and remains really an incredibly vibrant place to be to do the work of AI, which is not easy and not without risk, but I think the possibilities and opportunities are immense. And so I'm pleased to hear the kind of work that's going on and proud of what we have going on in the department. I'll keep the bio short because we have 4 speakers, so a lot to cover. The first is Logan. Is that no? The first is Jin. First is going to be Jin Ji, who is assistant professor in our division of gastroenterology here at UCSF Health. He also has a secondary appointment in our not so new anymore, but division of clinical informatics and digital transformation. And Jin is a transplant hepatologist, but his research really focuses on using clinical informatics and AI to improve the care of patients with liver disease. Second, I think, is Elaine Kuhn, who is assistant professor in the Division of General Internal Medicine based at Zuckerberg San Francisco General Hospital, also with a secondary appointment in this division we now call Doc IT. Elaine is a clinical informatician interested in leveraging technology and implementation science to improve health equity. Third will be Logan Pierce. Logan is assistant professor at a division of hospital medicine here at UCSF Health and also has a secondary appointment in Doc IT. He is an active clinician who combines his expertise in informatics with his clinical work to enhance healthcare delivery. He serves as the managing director of something I'm very proud of, which is the Department of Medicine Data Corps, which is a team of clinician data scientists who focus on clinical data extraction, analysis, and visualization to help the entire department, and for that matter, many other people at UCSF improve the quality of care and also do research. The fourth is Augusto Garcia Agundez, who's a postdoctoral researcher in our Division of Rheumatology based at San Francisco General. Augusto applies his knowledge in natural language processing and other AI methods to improve patient outcomes and quality of care in the field of rheumatic diseases. So it's a great group. The format will be each one will come up and speak for about 10 minutes, and then we should have hopefully 15, 20 minutes for a discussion. So I think, Jin, you are first.
All right. Well, just want to thank the organizers for welcoming. Sorry. Just want to thank the organizers for welcoming us and hosting us today. So I'm going to present our work on Liversa, which is a liver disease specific large language model And I think these are my disclosures. They include the usual research funding and also financial relationships, but I highlighted the thing at the bottom, which is in the red, that this is going to be much more important in the future, whether somebody uses generative AI in their presentations and so my disclosure for this is that I did not use Gen AI to write this presentation, though there may be Gen AI content that is shown in this presentation. So to sort of frame the discussion, I want to explain our motivation for Liversa, and I'll sort of like give a couple of statements which I think are generally true and very applicable in this environment. Number one is that accurate disease specific content is essential for Gen AI to work in not only just clinical applications, but specifically in specialty specific applications. And for example, in my specialty, transplant hepatology, I'm in liver diseases. Second is that if we can achieve accuracy, then Gen AI can really have the potential to transform how clinicians deliver care. And in my case, it would be liver diseases care. But as everyone knows, we cannot use Gen AI right now because they're not accurate enough. And I'll give some examples as to what are the things that we're seeing. Therefore, this is the motivation for Liversa, which is we built a liver diseases specific large language model to help begin to bridge this need. So when ChatGPT first came out in November 2022, Jennifer Lai, who's one of my mentors here at UCSF, and I looked at the technology and we published this, this article about how do we think about the potential use cases. And we did something called a SWOT analysis, which is strengths, weaknesses, opportunities, and threats. And we thought that there were a lot of various interesting applications, but the tech is still very, very new and we need to figure out what is going to happen. And so throughout all of 2023, we learned, at least within hepatology, that Gen AI can answer a lot of clinical questions. And there were a plethora of articles that were published during this time, basically about how ChatGPT can answer my questions about fatty liver disease, liver cancer, cirrhosis, and liver transplantation. But we also learned that these answers could be partially or completely wrong. And this was an article that was published from Italy, where a group ended up looking at the answers for can I use herbal remedies in fatty liver disease? And as a transplant hepatologist, when I see all these herbal remedies being prescribed, I get a bit of heartburn and also feel very uncomfortable because we typically recommend against these things supplements and herbal remedies because they're associated with liver injury. And so this is an example of something that I would consider to be wrong and that, that I would not recommend. And obviously, the most famous errors of ChatGPT has been the false references. And this was an example that we had run back in 2023, where we had asked ChatGPT to give us, basically try to answer some questions on tips and give some references. And you can see that these references look pretty darn good. They cite, appropriate journals with the appropriate page numbers. But if you actually go and look at those page numbers, they don't exist at all. So not real. And so this kind of gets to the problem or the solution is that accuracy is really, really essential for Gen AI adoption. And this is, part of my disclosures, this is a Gen AI generated image. But if we want to get to this future state where we can have all the doctors using artificial intelligence to improve liver health, then we really need to achieve accuracy. And that's the most important thing. And so what we did was that we partnered with the UCSF AI Tiger team, and we decided to use this technology called retrieval augmented generation. And I'll kind of explain to you what that means. But basically, what we did was that we superimposed a validated database of knowledge or information on top of the large language model so that when you query our customized large language model, the query gets sent to our customized database, and then that gets combined with the rest of the knowledge of the large language model, which creates the output. And so what that does effectively is that it constrains your solution space of potential outputs to only what is available inside the data you provided. So if you end up asking Liversa management about heart failure, for example, which is outside of its database, it's going to tell you that it doesn't know. But if you ask it about indications for liver transplantation, it will give you basically evidence or recommendations that are agreed upon by the American Association for the Study of Liver Diseases and the American Society of Transplantation. And so really, this was a close collaboration with the AI Tiger team, and we discussed with them about the sort of the concept, and then we basically built out the models, and they were able to deploy this very, very quickly. And ours was the first clinical Versa chat assistant deployed at UCSF. Now, if you guys know or have heard of RAG as a technology, this is actually the same tech as customized GPT. And so this was Sam Altman back in November 2023 when he introduced this concept. And this was right before he got fired, and we hired 5 days later. So, but sort of like going through mechanics, you give Laversa a prompt. It ends up searching the RAG database first, which is our AASLD, the Liver Society guidelines, and it comes back to the GPT software and ends up giving content-specific outputs. And so this is our interface. It's within UCSF Versa. If you have access to Laversa, you can click down on a menu and you can ask it questions about liver diseases. And we actually, now the question is that, does Laversa do better than ChatGPT or Llama? And we actually did a comparative evaluation. So we generated 10 different questions, general hepatology questions. We asked Laversa, ChatGPT, and Llama 2 to answer those questions. And then we had 15 transplant hepatologists review the answers to those questions on 3 dimensions. And these dimensions were accuracy, comprehensiveness, and safety. And what we showed was that Laversa basically beat Llama 2 on almost all measures. And it was more accurate than ChatGPT, but less comprehensive and safe. And this kind of gets to one of the problems with Gen AI content is that evaluations are very difficult because they are subjective. And this was the primary sclerosing cholangitis question. What is the most common type of malignancy associated with PSC? The answer is cholangiocarcinoma. Laversa gave a very short and pithy output, but ChatGPT and Llama 2 were had more character counts. And so we believe that people rated Llama 2 and ChatGPT to be more comprehensive and safe because of their verbosity, even though the information provided may not be different from Laversa. And so this gets to the point that we really don't have many great frameworks to say if a Gen AI content is accurate or not. And this is an issue that the community is dealing with right now. How are we deploying Laversa? Well, we have a pilot study going on. And the goal here is to basically try to identify patients with covert hepatic encephalopathy. And this is defined as patients who have a degree of HE that is not recognized by the patients themselves or recognized by clinicians and can only be detected on psychometric testing. And so what we're doing is we're recruiting patients with covert HE, normal patients, having them have a chat with Laversa about their liver disease. And then based on the responses of Laversa and also based on their questions, we're trying to figure out if it's associated with HE or not. And so the idea here is that the goal is to deploy this within a messaging platform such as MyChart, so that when our patients with cirrhosis are typing in their information, we might be able to catch if they have HE or not. So this is a pilot study. We just started to recruit patients, and we're really excited about the potential. So just a quick concluding slide. So commercially available Gen AI models are prone to hallucinations and inaccuracies. Therefore, they're not widely deployed in clinical applications. There are emerging techniques and technologies such as RAG that allows the customization of Gen AI models leading to more accurate outputs. Evaluations is still a very difficult thing to do because there's lack of standardized dimensions for evaluation and also subjective interpretation by humans. And then finally, we're going to start seeing a lot more of these pilot studies going on, such as Laversa, for the detection of minimal hepatic encephalopathy. So here are my acknowledgements. I want to acknowledge the AI Tiger team, who's been a very big part in helping to build all of this technology, and also my mentors in GI, CTSI, and my collaborators at CPH. So thank you.
Good afternoon. I'm really excited to present some of the work from our team. We've been using large language models to really improve language concordant patient instructions. I have no important disclosures, but do have some of the similar ones that Jin showed earlier, in just terms of obviously showing some Gen AI content. So just to make sure we're all on the same page, language discordance is super common in medicine, and it's associated with worse clinical outcomes, worse utilization, and worse patient-reported outcomes. And some of these disparities are mitigated through language access, meaning specifically interpreters, translators, or bilingual clinicians. But one of the challenges, particularly for written materials, is that it's often not translated. So this was a study that surveyed general internists, and you can see that about 30%, 30 to 40% reported providing no translated materials. And for important translated materials like informed consent, only about 50% made it available. And when you think specifically about tailored patient written instructions, so things like at discharge instructions or things specific to a patient, it's really hard to get that translated. Very few places have workflows for really generating that in real time. And in a study we did over here at Parnassus in hospital medicine, we found that when you provide patients with language concordant patient instructions, they were less likely to have questions about medications. So you can see in the blue line, our Chinese speakers before providing the language concordant instructions had a higher probability of having questions about their medications. But once we deployed these standardized instructions, we had a closing in a disparity. And so this is where lots of people have really been interested in machine translation because it allows you to really provide those tailored patient instructions. And so just to provide a little bit more context about our study here, I want to show you some of the findings we had from a prior study where we used Google Translate to actually translate patient instructions into Spanish and Chinese. And there were some challenges. So the accuracy you can see is about 80 to 90%, depending on if it was Spanish or Chinese, but almost 10%, at least in Chinese, had harmful mistranslations. And when you look at the type of sentences that Google Translate at least struggled with, it was the predictors were really having a high Flesch-Kincaid score, meaning that it was written for somebody at a high literacy level, focusing on follow-up instructions, or having medical terminology, spelling errors, or using colloquial English. And I want to give you an example of what this looks like to help explain why a large language model might do better with providing better translations. So this is just an example. So this here was a sentence with written at a high literacy level. So you can see it's, please follow up with your primary care doctor to get a refill on all your medications and seek immediate medical care if you develop confusion, severe abdominal pain, or nausea, vomiting. So there's a couple commas missing. It's like a complicated sentence, but not an uncommon sentence for any clinician in the room. And you can see because of the complexity of the sentence, the back translated Chinese version said, if you feel confused or have these symptoms, please go to your doctor to get your medications refilled. So the multiple clauses really caused challenges in the translation. Another example here is holding a kidney medicine, which actually might also be confusing for an English speaker as well. But for both Spanish and Chinese, this was translated into to continue the medication, which is of course the opposite meaning. And then lastly here, this one's a little funny, but there's a typo. It says you have a low back stain instead of a strain. And it was translated into having a low patch on your back in Spanish and a low back spot in Chinese. So these are errors that a machine translation tool didn't do well with, but you can imagine that a large language model with the context might better understand the meaning. So our research questions, I'm going to really focus on the first one, but we'll give you a little insight in the other ones, was first just how did Google Translate compare the GPT in translating instructions into Chinese, Spanish? And we added Russian this time around just because studies have shown that under-resourced language tend to do worse in machine translation. And then the other things we were exploring is whether or not GPT can be used to rewrite patient discharge instructions to increase the likelihood of accurate and safe machine translation. And how do patients actually feel about the rewritten instructions? We as clinicians may feel like they look better, but do patients feel the same way as well? So we used 50 set of ED instructions, 25 from here at Parnassus, 25 from the general. We translated it into Chinese, Russian, and Spanish using Google Translate and VersaChat. And then we back translated it into English by professional translators. We compared that back translated English version to the original English based on 2 clinician review. So really going towards what Jin said before about sort of subjective assessment, this really is quite intensive. So we had 2 clinicians reviewing the accuracy, as well as assessing for potential for clinically meaningful harm if there were any mistranslations. So ultimately here, what you see we found is that GPT was significantly better than Google Translate for both Chinese and Russian, but no significant differences for Spanish, and there were no significant differences for harm. And similar to our prior study, some of the predictors of inaccuracy in Chinese and Russian were focusing on return precautions, where you tend to see sort of those long sentences with a long list of symptoms, having any grammar errors, and then a high Flesch-Kincaid score. So just to give you an example here. So this was a sentence, the original sentence, the MRI did not show any new fractures, broken bones, and the bone specialist recommends that you follow up in their spine clinic. So GPT, recognized that the MRI just didn't show any new fractures. It recognized the broken bones, but Google got thrown off a little bit by the parentheses around broken bones. And you can see here what they ended up writing is that the MRI did not show whether there's a new compression fracture in your spine. And then for any new fractures, the orthopedic specialist advises follow-up. So really struggling a little bit with some of the parentheses of the broken bones. Another example here is, again, we see the hold the kidney medicine, which again in Russian and Google was translated to continue the medication, whereas GPT accurately recognized that was saying, do not use your kidney medication. And then the last example here, there's just a small typo. It says follow up with orthopedics in regards to fracture. So clinician likely meant in regards to your fracture, in regards to the fracture. And that caused confusion for Google. It said follow up with orthopedics in case of a fracture, whereas GPT again recognized you're following up with orthopedics regarding your fracture. So just going to the next couple of questions here. We then asked GPT to rewrite the discharge instructions, and then we're also to translate the rewritten discharge instructions using Google versus GPT to then see, once it was rewritten, does GPT still do better? So for those of you who have a little bit more familiarity with large language models, you recognize the importance of the prompt that you put into the chat GPT when you're asking them to do something. So this is the prompt we use. We use the Risen framework. We said, act like an ED doc communicating written discharge instructions to a non-English speaking patient with limited health literacy. Rewrite the discharge instructions to optimize understanding and accurate machine translation. And the goal is to rewrite it while keeping important content. And we added these constraints about no medical jargon, no abbreviations, no spelling errors, and to keep colloquial language to the minimum based on our prior study showing those caused issues. So if we go back and look at those three sentences I showed you earlier, you can see the rewritten sentences by GPT. So the first sentence, because I guess we asked it to remove acronym, it's changed MRI to a detailed picture and just simply said you didn't see any new injury. So it took out that parentheses about broken bones. The second sentence, it increased the clarity by just changing hold to really pausing the kidney medicine. And then the third sentence, it fixed some of the grammar issues. So please see an orthopedic doctor about your fracture. So I want to just show a longer example and get you some perspectives from the patients about how they felt about these rewritten instructions. So this original set of instructions, you can see the clinician says you were evaluated in the emergency department and the clinical decision unit for neck pain and upper extremity weakness. When we asked Versa to rewrite it, it just removed out the component about the clinical decision unit and then changed upper extremity weakness to weakness in your upper body. And you can see in red a couple other places where it made changes. It changed MRI to detailed picture. Evaluated by neurosurgery was changed to check by a surgery doctor. And then the Medrol dose back on the left was changed to steroid medicine. PCP was clarified as sort of regular doctor. So it sort of made a couple of changes based on the constraints we provided. What we then did is we translated these two sets of instructions into Spanish and we showed them to a Spanish speaking patient. And this Spanish speaking patient really strongly preferred the rewritten instructions. You know, they state, and this part of the original instructions with the recommendations is confusing. But in the rewritten instructions, I understood all the instructions they're giving. They're sending you to therapy, they're giving you oral medications for pain and injections, and to call your doctor in 5 weeks. So the rewritten version is explained well. The words they use explain things better. And the original version was not clear, but this rewritten version was well specified, so I understood it better. So this is sort of an example of how, you know, asking potentially GPT to rewrite some of our own instructions might lead to better machine translation. In this example, we'll give you a perspective from an English-speaking patient who ultimately preferred the original instructions. But what you can see here, GPT did is it took CT scan out and changed it again to just images. Hemoglobin was changed to red blood cell count. And the clinician in this original set of instructions actually copy and pasted the entire X-ray read. GPT just simply took the entire X-ray read out of the rewritten instructions. And so this English-speaking participant ultimately preferred the original instruction set, but you can see them weighing sort of pros and cons of the two versions. They said you would probably get a better understanding of the rewritten version. It pretty much broke everything down that they checked out. But the original version expresses more of the imaging and the different findings they found. Even though they didn't see the broken bone, they did see other things like a dual LED pacemaker. That wasn't mentioned in the rewritten version. And it gave me more detail of what was going on. The right basilar opacity representing infection, she didn't get that detail. So for me, the original version is more detailed of everything that went on with the x-rays, but the rewritten version does get pretty much straight to the point, even though that person wouldn't really know what's going on like they would in the original version. So really weighing the pros and the cons. Just want to briefly go through some of the hurdles that we can talk about a little bit more in the panel. But we designed this project pretty early in 2023, and we weren't actually originally aware of UCSF's policy on using large language models. So we actually submitted the study through the IRB, and the IRB actually didn't flag any issues for us. We actually got flagged when we submitted our purchase order to work with a translation vendor, saying that they needed to undergo IT security assessment. And at that point, we got connected to the CTSI AI team, told us about Versa. And originally Versa Chat was only available in 3.5. And our team didn't quite have the technical expertise to use the API for 4.0. So we were sort of weighing the pros and cons of using each product until Versa Chat became available in 4.0. And so we ended up using Versa Chat. But the policies for DPH data actually weren't clear and still aren't entirely clear. So we just followed UCSF Health's policies on using Versa. So I want to quickly acknowledge our really, really large study team. We used a ton of clinicians for this review, and I want to call out Anderson Yang, our project manager, who really has been wrangling a lot of clinician schedules and really managing a lot of sort of the data sets going back and forth in multiple languages. And of course, the AI Tiger team for answering our questions. Pass it off to Dr. Pierce.
Thank you. Thank you, everyone, for having us here today. Okay, I'm going to start off with just a quick slide about myself. Bob already introduced me, but I'm the managing director for the Department of Medicine Data Core Group. So in that role, I do a lot of data work. I code in SQL and R, and that's primarily how I use ChatGPT, is using R. And I've been using ChatGPT for about a year, at least for clinical applications, which was shortly after Versa was rolled out at UCSF. This is my own take, having worked with ChatGPT on a number of clinical projects, on how I think ChatGPT does on various buckets of problems. And it kind of goes from most fundamental to most complicated. And so I'm just going to talk about two of them today. How ChatGPT can extract data from unstructured text, so from clinical notes, basically turning that into structured data that can be used for a variety of things. I'm going to skip over text summarization, although I think it's very good at that. So like summarizing the chart, very useful. I'm going to talk a little bit about novel text generation. So it could be patient instructions. In this case, I'm going to talk about informed surgical consent documents. And then the last one is like problem solving. Again, like Jen said, asking ChatGPT for recommendations. I personally don't think it's quite there yet, but I think it will get there. So I worked on a project recently looking at ChatGPT and how it generates surgical consents compared to actually what surgeons use. In this project, I do want to call out Hannah Decker and Karen Trang. They're a couple of general surgery residents who led this work. And they couldn't be here today, but this work wouldn't have been possible without them. So the goal of this study was just to look at how ChatGPT compares to what we really use. The goal of surgical informed consents is to ensure that a patient understands the risks, benefits, and alternatives to surgery. And then there's some more general recommendations that it should be readable, accurate, and complete, and delivered at a 6th grade reading level. So for this study, we regularly audit surgical informed consent documents at UCSF. So we randomly selected informed consent documents from 6 common surgical procedures across a variety of surgical specialties and compared those with basically a surgical consent document that we got from ChatGPT. We use ChatGPT model 3.5, which is kind of the earlier model, and we use the web-based interface, basically going to chatgpt.com. This was the prompt we used. It doesn't get much more simple than this. Explain the risks, benefits, and alternatives of the procedure to a patient at a 6th grade reading level. Again, we used the web-based version. That's all we put in, and we used ChatGPT 3.5 in part because this was done a year ago. And so that's the one we used. Outcomes. So we graded the surgical informed consent documents on readability and then accuracy, completeness. For readability, we used an online tool that measured the education level required to read the document. And so ideally, you'd want 6 or lower if you wanted it to be a 6th grade reading level, but scores range from 0 to 20. And then for accuracy and completeness, we used a rubric that was developed by Leapfrog and the Joint Commission and the American College of Surgeons. And for measurement, we asked surgeons to rate the documents. They were blinded to whether it came from ChatGPT or a surgeon. And we excluded informed consent documents from the surgeons that were actually doing the review. And what we found is that in many cases, basically the ChatGPT informed consent documents were non-inferior in many cases. So for benefits and alternatives, they were rated significantly better than the surgeon-generated documents. For risks, they were roughly equivalent. And for readability, they trended towards being better. Although you can see that those scores, 15.7 and 12.9, those are the reading, the education level or number of years of education to read it. So neither one is particularly close to 6. But the ChatGPT one is a little bit lower than the surgeon one. This is the breakdown by procedure. So I mentioned we looked at 6 common procedures, and you can see some variability across the procedures, although in general for readability, the chatbot or the ChatGPT generated document was better. For accuracy and completeness, pretty much the same. You can see risks, at least for some of them, like knee arthroplasty, the surgeons actually scored better, but for most of them, again, the chatbot scored a little bit better. And overall, either the overall impression or the composite score, the chatbot was better, or scored higher at least. So conclusion is that this suggests that maybe embedding LLM-based chatbots into the EHR to generate surgical informed consent documents might be beneficial, but some big caveats here. One being it's still not even close to a 6th grade reading level. We only looked at 6 common procedures, so maybe less common procedures might not perform as well. And there is variation from procedure to procedure, so you would probably want to validate any of them before rolling them out. But still, I think it shows a lot of promise. And it could definitely ease the documentation burden for physicians and improve the experience for patients. The other thing I'm going to talk about is using ChatGPT as an NLP tool. As in my role as managing director of DataCore, I've used NLP for a while to try to extract data from clinical notes, and I will say it's challenging even at the best of times. Prior to ChatGPT, I was using CTAKES a lot, which is a program that's supported here at UCSF that basically extracts medical concepts from notes. But those concepts have to exist beforehand, and there's still a lot of problems with negation. So this is not atrial fibrillation, or it's suspected atrial fibrillation. But that was kind of the standard and the best thing that was available. So this is a dashboard I built for fellows in infectious disease and HEMONC. And what it does is it extracts the diagnosis mentioned in clinical notes. You could use ICD codes, but those are coded to an encounter. This basically says, what is this note talking about? And you can imagine using this for a variety of purposes. Here, we're using it to make sure that fellows in these fellowships are seeing an appropriate breadth of cases. And so it's being tracked by their program directors. But it's just one example of taking unstructured text and extracting something meaningful that you can then display in a dashboard or use to drive different workflows. This is the prompt we use. Again, relatively simple. You're a physician working at an academic medical center. What's the main diagnosis? And I had to limit it to 4 words. Being treated in the following note. And then I insert the note here. So for this, there's many notes written every day. It would be labor intensive and not really feasible to use the web-based interface. So I use the API here. Again, I mentioned I coded in R, and so I looped through all the notes of a day. Again, I use the ChatGPT 3.5 model, and the cost is about $0.01 a note. I said about because it's actually based on tokens and how long the note is. But if you look at it, it's about $0.01 a note, maybe a little less. But that is for the 3.5 model. The 4 model and the other models can be more expensive, maybe even 10 times more expensive. So conclusion, I really like it as an NLP tool. I'd say it's my go-to tool. One of the biggest pros is that it's very flexible. I can ask it anything I want. I'm not limited to the concepts and the UMLS terminology. For example, if you want to ask about food insecurity or surgical site infections or domestic violence or things like that that are not medical concepts yet, you can do that with ChatGPT. You can't do that with CTAKES. I also think it's a little easier to use, but the cons, it does hallucinate, so you need to validate everything, and there's a cost to it. So just a summary of how to access Versa or LLMs at UCSF. There's 2 main ways: the web-based interface, where you can copy things in, including clinical notes, as long as you're using Versa, not the OpenAI ChatGPT. And it's very easy to work with. It's free to use, but it's manual data entry. The other version is API, is to use the API. You can automate things. It's very reproducible, which is important for research. But you do have to have some programming expertise. If you don't have that and you're interested in using it, though, you can always work with DataCore, and we can support projects that require ChatGPT.
Thank you. Good afternoon. So the project I'm going to describe also made use of the Versa application programming interface. I hope it provides an idea of when it's a good idea to use it and what it can do for you. For a little bit of background, the way I like to think about Versa is a language calculator. The same way that you would use a calculator to do operations with numbers, you can use Versa to do operations with language. So you can use it to, for example, generate new documents, translate, summarize. It is also, even though it doesn't contain knowledge itself, it is useful for question answering if you provide the right context, either as part of the prompt or through the retrieval augmented generation process that Dr. G described. And the other function is what Dr. Pierce just described. You can use it to extract information, especially through the Versa API, because you wouldn't have to paste all of your inputs in the prompt, but you can cycle through your data set, an Excel sheet, on whichever form you have it, and extract systematically from that set. And for a little bit of added background on my presentation, there are other ways in which we can improve the performance of this model. So the way you use the model regularly, it's what's called zero-shot learning. So you present the model with a new task it hasn't seen before, and it will do reasonably well. That's how you use VersaChat or how you use the OpenAI ChatGPT model. However, research indicates that if you provide examples as part of your prompt, that can have an impact in your accuracy and can make it much, much better. Finally, the other option I'm going to present is to use the output of models to train smaller, more computationally efficient models that we could host locally. For a little bit of background on our experiment, so of course, having accurate dosing data is very important for medication safety studies, for clinical decision support, and for most medications, you are not going to have to look in detail into this because you have structured data like the pill size or the frequency. However, for some drugs, for example, for immunosuppressive drugs, the most accurate source of information is the medication instruction, which is free text. So we needed to process this through natural language processing. And unfortunately, the more classic methods that Dr. Pierce just described do not adapt well to these instructions because they can be quite complicated. So the question we set out to answer is, can we actually use the Versa API to annotate these medication instructions to extract the average daily dose from two immunomodulating drugs, in this case, hydroxychloroquine and prednisone. And we had a manually annotated data set of 700 hydroxychloroquine instructions and 20,000 prednisone instructions. Fortunately, of course, this is still a relatively small data set. And if your data set is even larger because you're working, for example, with a national registry, this can get quite challenging. So it was very interesting to see how well Versa would do on this. And what we found out is that essentially both GPT 3.5 and GPT-4 did pretty well. Of course, GPT-4, it's a bigger and better model. It did quite better. We actually found out that GPT-4 without examples does better than GPT 3.5 with examples in this few-shot approach I presented. And GPT-4 with examples is actually very, very accurate. And for a little bit of added context, you can see here how accuracy goes up as more examples are provided as part of the prompt. So both models see quite a bit of improvement as more examples are provided, even up to 100. It was a little bit surprising to see that both 3.5 and 4 essentially gained accuracy at the same rate as more examples are provided, but both did pretty well. However, the other angle that is important when you look at this graph is cost. Because if you just provide your instructions and use one medication to annotate, that can be relatively cheap. But if you're providing one example, your cost is suddenly twice. If you provide 5, it's 6 times the cost. So if you provide 100, this can get very, very expensive if you need accuracy. So what we set out to do next was to see if we could train a much smaller model. So for context, the model I'm talking about, Bluebird, is less than 10% the size of GPT 3.5. It can be hosted locally on your computer. It can be trained. So it is very, very efficient. What we did is we used 75% of our data set to train this model. And when I say train, these models already have a degree of language understanding because they're usually pre-trained in data sources such as PubMed articles or publicly available clinical data sets. So it's just a matter of training it for a little bit longer to do better on the task you specifically want it to do. And just for a bit of comparison on what that means. So annotating our data sets with Versa costs us around $3,000. Of course, there's no training time. You can run it instantly, but it can take quite a bit to annotate large data sets because you're not the only user on Versa. So it actually took us around 8 hours to annotate the complete data set. As a comparison, Bluebird was free to train because we used the Winton UCSF computing cluster. It took us about 3 hours to train it for this task. But once it's trained, running it is essentially instantaneous because it's very small and efficient. But of course, we would need to see how well it performs. And what we found out is that it did more or less as well as GPT 3.5 with examples. So it doesn't reach that GPT-4 level of accuracy, but it reaches an acceptable level of accuracy at a much, much lower cost. So of course, depending on the degree of error tolerance and depending on the task you're implementing it for, it can be a very, very useful solution, especially if the information you're looking for is not as implicit, but is very explicitly mentioned in the text. It is a very, very accurate approach as well. And fundamentally, the takeaways that I want to leave you with is that, yes, Versa is a great tool for information extraction. It can save a lot of time and a lot of clicks for tasks like chart review, for research. Of course, the problem is that if very high accuracy is needed, a lot of examples are going to have to be provided, and this can get very, very expensive. And as a comparison, this distillation process of training a smaller model, even with Versa annotations, can be very, very efficient. And it is also important to keep in mind that we have all the necessary means to do this at UCSF because we have Versa as the central annotation tool. We have the Winton computing cluster. We have the clinical data warehouse with a lot of free text to train the models with. Thank you very much.
They come up and get in chairs. Fabulous. So let me start with a version of translation of my own. Is it fair to say that Versa is GPT-4, whatever it's using, that just has firewalls around it? And if so, what is it getting from the GPT-4 corpus, which is looking at the entire internet, I imagine, and what is it getting from the local data? So I'm still not entirely clear how these two things, this sort of local environment that you've created by it being Versa or by being this distilled knowledge base that you've entered in, how that interacts with the entire corpus of information in GPT-4, which after all is all of the internet, including PubMed, but also including the Onion. I mean, there's information and there's bad information out there. How do those two things interact? Can anybody explain that in plain English? Maybe not 6th grade level, but maybe try 10th grade. Anybody want to try?
Sure. Do you need a mic?
Oh, we need mics, yeah.
Sorry. These two.
Yeah. So my understanding, and I hope this isn't wrong because I've told people this, is that it's Versa is ChatGPT with a firewall. It's the same model, and when you use it, you can choose 3.5, you can choose 4. There might even be other models you can choose now, but it is the same thing. You know, if you go on the paid version of ChatGPT, they're adding new features all the time, and sometimes it's more up to date. Ours might not get that refresh every, as often, but it's basically the same thing with a firewall. So you can put PHI in there. That's the big difference.
So the data you're putting into it is not going out into the real world, but the data that is all of the trillions of pieces of data that are in GPT-4 are what it's using when it's doing its calculations, not just using the data inside our world.
Yes, and it doesn't read the chart. It doesn't know UCSF data either. You have to input that in your prompt. So it's basically, like you said, ChatGPT with a firewall.
Okay, and then it sounds like both Jin and Augusto have done things where they're not only taking that, but they're putting in or inserting a very specific set of data to constrain it or to teach it stuff that it would not learn from the internet. Is that fair?
Yeah, so just to clarify that, so the AI Tiger team is actually building a set of assistants where you are able to basically put customized data on top of the Versa Chat baseline platform. And so that's the foundation for what we did with Versa with clinical content. But I believe that they've developed assistants for administrative content, nursing content within UCSF as well. And so those are other assistants that you can be using.
And I'd love to hear August's take on this as well, but I assume there will be time, because it is reaching out to GPT world in addition to the data set, the liver stuff that you inputted. I assume there's conflict at times that the liver database tells it X and GPT world says, take this herbal thing for your fatty liver. How does it reconcile that conflict by always assuming that if it finds something in your customized database, that trumps everything else that it could find in the rest of the corpus?
Yeah, so the way that the retrieval augmented generation works is that it always searches your database first, and it takes that as the default sort of like set of solutions that it then sends over to the rest of the model. And so your stuff is always the sort of like the proper answer, and anything that's conflicting is not. Now, this is a question that our lab is actually really interested in, is that if you put in information in the retrieval augmented generation database that is fundamentally conflicting, and you can see this with the AASLD recommending one thing, but the European guidelines saying another.
Right.
What happens when you put both guidelines in there, and how that behavior or conflict is going to get reconciled? And so that's actually an area of research that we are pursuing right now.
So we don't know at this point sort of how it will reconcile disparate information. You see that, you can look through the chart of a patient to do MedRec and see 9 different versions of their medication list. So how does it know what the right one is? And we don't know in this case what it's going to come up with. Yeah.
We don't know. So we're experimenting it.
Okay. August, anything to add in terms of your experience?
Well, the thing that's important to keep in mind is these models have a very wide, it's called context window. So how much text you can input. So the more context you provide, the better it's going to do. And the context will always override what's underneath. If your data exceeds the context, you can use retrieval augmented generation. And if there are contradictions within that data, unfortunately, I don't know how that reacts, but as long as you provide the right context, you can expect the answer to be accurate, even if the training data that was before was inaccurate.
Interesting. Elaine, you talked about the importance of the prompts, and I guess as I follow this world, it seems like people are talking about the prompts becoming less important over time. What are you finding, and how important is it to give it the right prompt?
Hello. Okay. We played around with the prompts a little bit for our study, and one thing we did was, as Logan pointed out in his too, is initially we had put in a prompt to make the reading level below, I think, 8th grade level, and it ended up removing so much detail, like it didn't even describe anatomy sort of correctly. Like it was so vague. So we ended up actually taking that part out of it. So we didn't sort of iterate on the prompt afterwards, but I think some of the folks here have more expertise, but at least my sense here is that at least when we're talking about patient-facing communication and using, like a chat-based product for clinicians, I do think the prompt is still really important in terms of what you're going to get out and how that communicates to the patient.
Yeah, I guess I was a little surprised, Logan. Your reading level, you specified you wanted 6th grade, and it gave you 11th grade.
Yeah.
Or I would assume that's an easy thing for it. Like it knows what a 6th grade reading level is, and I'm surprised it would whiff on that.
I mean, it whiffs on things. It's just really like a pattern recognition. It's just predicting the next word. And so even on my other example where I asked for 4 words maximum for a diagnosis, sometimes it would give me 5. So it does. And you kind of have to be aware that that's a limitation. I do agree that I think the prompt really matters. I worked on another project trying to identify infections, and I asked for, does this note mention purulence? And that gave me some examples, but I was missing some. And then I had to ask for like fluid-filled collections. And you really have to iterate. And I do think the prompt makes a big difference.
Okay. Elaine, did you want to say something?
I was just going to say that I think, we've seen these large language models struggle with like math. And I think it's sort of the same thing. You can designate it as a certain reading level, but it's not actually calculating the reading level.
Yeah. And go ahead, Jed.
And I think one of the very interesting things that we're finding, we did a very similar exercise about like asking what is cirrhosis, or like is there cirrhosis in a discharge summary? And our experience has been that yes, GPT can be inaccurate and can be wrong in about 6 or 5% of the time. But when you put that question in front of humans, they're also wrong about 5 to 6% of the
Right,
time.
right.
So then who's right and who's wrong? And this kind of goes to the idea of how do we really evaluate the outputs if it's so subjective?
Yeah, this comes up all the time as we talk about, well, the human in the loop, and the human has to be the final arbiter. The humans are wrong a decent amount too. And there actually are going to be times where the AI is right and the human screws it up by weighing in. Maybe I'll ask one more question, then we'll open it up. None of you really talked about using this for diagnosis or kind of nuanced clinical decision support. Logan, you mentioned it, and basically to then say it's not ready for prime time. Sarah Murray, who runs AI for the health system here, told me a few weeks ago that one of her observations is we thought that something like chart summarization was really much more benign, and it's okay. It's ready for prime time for that, but suggesting diagnosis is not. And at least I'm paraphrasing, I hope I get this right. Her impression was that that may not be entirely right, because diagnosis is so core to our being that you're going to look over the list and you're going to say, oh, that's clever. I hadn't thought of that one. And this one, that's screwy. I don't even worry about that. Whereas chart summarization, by its very nature, you're doing it so you don't have to do it. So if it throws in a hallucination, if it makes up a diagnosis or omits something really important, you'll never catch that. Does that ring true to you?
For me, definitely. And, as a clinician, I have put in cases to see what diagnoses would come up. Just like you said, some are way out of left field. Some seem kind of right, maybe even prompt another lab test. But I think the concern is people not doing that and just saying, well, this is right. Or I've, said, okay, this patient has meningitis. What antibiotic should I give it? And it didn't give what I would normally give.
Yeah.
And so if you don't have that healthy skepticism, you have the potential to cause harm. And I think that's where the biggest concern with using it for clinical recommendations is.
Yeah. Jin, is that your sense as well?
Well, I think this is where there really is a role for these sort of specialty or disease specific language models, because that was sort of the concept that we were working with, was that if we can make something that is specific to hepatology, can we deploy it in a way to help with diagnosis as well as giving recommendations? And so, we're still in the process of trying to get a pilot started on this idea of using Loversa for e-consults. We're still doing a lot of retrospective reviews on that, but it's I think everyone within the liver transplant unit are really curious at how this is going to work out, and there's a lot of enthusiasm to, let's start using it.
But it sounds like you would be skeptical of replacing an e-consult. I'm sending you an e-consult about a hepatology patient with GPT-4, but you might be interested in at least looking at, can we review the last 10,000 e-consults on similar questions in this system and see what answers it gave and model what the right answer is? You think that's more likely to be accurate?
So I don't think you can take the human out of the loop yet. It's not going to be answering any e-consults by itself. But I think the way that a lot of what we're seeing in hepatology e-consults is workup for elevated LFTs. Well, the AASLD has a guideline for that about how do you work up chronic liver diseases. And so really searching into the guidelines and then having some recommendations, the human may say, okay, this sounds reasonable. Let's approve it and let's send it out to whoever's requesting the e-consult.
Okay, let's open it up and say who you. I probably need to do the mic here.
There are ceiling
mics. All right, why don't you just say who you are and start this.
Hi, my name is Justin. I'm one of the internal medicine residents. And this question is a little bit more specific to Jin's presentation. But just kind of to your point about the fact that the public large language models like ChatGPT or Claude are trained across the entirety of the internet. And how there's a need for a more medical specific or even a subspecialty specific one. I was curious in your work or in your future directions, whether you were planning on looking at using something like using products like Open Evidence, for instance, and kind of comparing those, just because at least from my own personal use, it seems like it seems to be a more efficacious and useful platform as opposed to using ChatGPT.
Yes, that is on our radar. Have I done it yet? No, we have not done it yet. But I think it gets to the question is sort of I do feel that there is a sweet spot in terms of what you put in for your customized information. And you get to that point where if you have too much information there, then they start becoming conflicting and your marginal yield becomes much lower. And this is actually an area that we want to explore is with the RAG technology, how many guidelines is way too many guidelines for accuracy.
Yeah, all in the back.
Hi, I'm Mayra. Nice to meet you with pulmonary and critical care and lung transplant. I'm really interested in this idea of getting diagnosis from charts. And I just wonder, can they recognize like PDF documents, or does it have to be a text, like, or if there's any way they can recognize text from images or other files?
ChatGPT requires text as an input, but there are other tools that can convert PDF to text. And so you could do that and then feed that into ChatGPT.
Okay, great.
Hey there, thanks everybody. I'm Eric, medicine resident. I'm just curious about the phenotypes of the errors that occur and sort of if you guys have done kind of clustering or analysis on the different types of errors you see the chat model make. In particular, Augusto, I think with your example of average daily dosing and the 20% of cases that are given the wrong daily dose, is it other indications? Is it just a random number? I'm just curious to see what patterns of behavior you see underlying there.
Well, as Dr. just mentioned, these models were notoriously bad at math. They have gotten a little bit better in the past few months. Generally, the mistakes the model would make for this annotation task would be just basic math errors. But I mean, in the world of ChatGPT in general, the problem of the errors is that the model speaks with authority, whether it is right or wrong. So one has to be very careful to make sure that what he's saying.
So
is
do
right.
many physicians.
That is actually, so the nature of the errors varies. In this case, it were math errors, but it's more important to be wary that the model can make a mistake and just be completely unaware that he's saying something very wrong.
Yeah.
Oh, I'm Salman, hospitalist. A question I had is just seeing kind of the future of the institutional specific work that you all are doing, and the possibility of having that be integrated, as Logan, you mentioned, into the EHR where you can do that. Do you see 5 years from now that this is something UCSF would integrate some institution specific models or use cases of GPT, or Epic is going to release some, widespread thing that we would be using their models, even though we think that we might have better models, institution specific? Just curious about that.
And what would make them, would they be better because they are institution specific and there's something different about the way we practice here? Or are they better because if it's institution specific, we just like it better and because of hubris? So.
I guess it's a little bit of predict the future. If I had to guess, I would say Epic will roll this out. They're currently working on it, and things that come from Epic are generally better maintained. That being said, while we wait for that to happen, lots of people are working on exciting things. Epic can't do everything, so I think it'll probably be a hybrid, but when Epic rolls something out, which they will, it will probably replace things that already do the same thing. People will use the Epic.
But is a future world one in where like we have to have a GIN in every single specialty who's massaging the data and doing the programming and entering it? Or I mean, is it that level of specificity going to be necessary? I guess Logan's saying that Epic's going to do some generalist model that works for everything.
I think they'll do a generalist model, and then everybody will also buy GIN's model, and that model will be adapted for liver-specific things. So it'll be a hybrid, but I think when Epic rolls out a tool, everybody typically adopts that.
Yeah, gotcha. Or yeah, go ahead.
Epic already has been piloting, right? Like using Gen AI for patient messages, right? So I think, like Logan's saying, is like Epic is going to roll out certain use cases that seem high priority for lots of health systems, or things that are like liver specific, right? Like if there's an institution that doesn't have a liver transplant team, that's not what they're looking into. And so I think institutions will sort of supplement, but if Epic rolls it out, that's sort of how things go. When they roll out bad screening questions, that's what everybody uses because that's what's in the EHR.
Yeah,
I think two perspectives on this. One is that I feel like this question should be better posed to Sarah Murray and Idison, who probably have more sort of authority on this area about how do we implement Gen AI in a clinical realm. But the second thought process is that even within some of the experiments we're doing, we are already moving towards the institutional specific configurations, even with Laversa. Because what we found in our testing that certain e-consults in retrospective analyses were answered a certain way, and Laversa was not able to sort of accommodate that because it was based on the national guidelines. And so now we're in the process of sort of putting in UCSF specific protocols so that it aligns with what our clinicians are doing. And I think the other third comment, which I'll make, is that when Epic are implementing the technologies, they're not really taking into account the usability from a clinician standpoint. And so, you know, you can imagine like how many tabs there are in Epic, and it's just completely information overwhelm. And so I feel like there's still going to be a role for customized rollouts, especially driven by clinicians who actually deal with the software every single day and are able to put it into the most intuitive ways for actual clinical workflows.
I can say the battle that's happening nationally and internationally is Epic has the advantage of sort of they're on your desktop, you trust them, you know they'll be in business 5 years from now. And it's not so much a competition between Epic and Jin's work, it's a competition between Epic and a startup that is a specific hepatology startup. But an organization will say, I'm not sure they're going to be in business, and they're probably going to be better because it's all they do is hepatology. But will they be in business for 3 years? Will they integrate into Epic seamlessly? Epic has that advantage of, you know, they're going to be around and the integration is built into the product. Maybe take, Lakshmi, you have one from online?
Sure. So you talked about in Dr. Kuhn's research about the patient actually assessing the accuracy of instructions. Was there similar patient-facing testing in the surgical consent project with Dr. Pierce?
No, there wasn't. Although that's definitely, you know, something you'd want to evaluate in the future for sure.
So let me ask one last for all of you. You've all decided, reasonably junior faculty members, to get into this as your career focus or a major career focus. Can you just talk we only have about a minute left, sort of advantages, disadvantages? Would you recommend if a medical student came up to you and said, I'm interested in AI and tech, I want to do this, would you tell them great idea or bad idea, or what would you say? Augustine, you want to start?
I mean, I got into the field of natural language processing just as the technology behind ChatGPT was starting, and I was able to see what a huge difference it made. I think it's going to continue to change as much, and I think every physician is going to have a degree of knowledge on how to use these tools for both for their clinical work and for their research work. So I think it should be part of the teaching curriculum. To what extent and how exactly is a very open-ended question right now.
Thanks, Logan.
I would definitely encourage people to get into it. It's the most exciting tool I'm currently using, and I still think it works like magic. So definitely.
Magic's good. Elaine?
Yeah, I would echo those sentiments. I mean, I think as you said in the beginning, right, you think it's going to revolutionize medicine. So I think any medical student is probably going to at least need to become familiar with it and understand how to leverage it in their clinical practice.
And for someone like you who's primarily a researcher, the funding stream for this kind of work, okay, not so good?
I'm still funded now.
Good.
So yeah, I mean, I think there's going to be so many use cases for using this as sort of a methods, and it doesn't even have to be, you know, like very core, like focusing on the revolutionary uses of large language models. Like it's going to be applied through all types of research. And so I think being able to talk about how you can leverage it to achieve your research aims will be really impactful.
And before we hear Jen, just the last comment, I'm doing a little tiny bit of lobbying for you that because the clinical system at San Francisco General is not run by us, it's run by the city and county of San Francisco. We really need to partner to be sure that we can have access to the data and have access to tools. At least my experience so far is it's easier here than it is there, and that's going to get in the way of some of the important work that people like you are doing.
Yes, agree. Completely agree.
Jen, will you be the last word?
Yeah, I would say that this is probably the best time to get into this because the technical expertise needed is starting to go down, and it's going down dramatically. Sort of like piggybacking what Logan said, a lot of coding that I do in SQL R and Python, I actually don't write the codes directly now. I actually ask GPT to write the codes, and then I double check it to make sure it's okay. And so as long as you got a good idea of how programming works, like you can actually get into it pretty quickly. And so I think the clinical knowledge is actually going to be more important going forward, and just some baseline technical knowledge to do this work. Funding wise, well, we were very successful in getting pilot grants last year to fund some of our more interesting ideas. So we got a project that is extracting social determinants of health from liver transplant evaluation nodes. We got that Laversa hepatoencephalopathy project funded. So it's a very, very good environment right now, but I don't expect that to last because people are just like wowed by the tech and they want to do something cool. I think in a couple of years, the funding may actually start being a little bit more difficult.
Yeah, great. Thank you all. Really terrific, really interesting and important work.